see how we can make a simple Python bot that can play this game by itself. The idea is to understand Windows automation, and towards the end, I'll tell you what's the next project that's going to depend on this information. Here we're using PyCharm, and there are a couple of libraries that we need to install. We'll use pip install PyAutoGui, and this is the main library that we will use in order to understand the graphical user interface for the Windows system. Then we need keyboard. This keyboard is used to understand and do or simulate key presses on a keyboard. The next is PyWin32. This allows us to take information from the Windows system. So these are a few libraries that we need to install, and I'm doing it here in the terminal folder of the same project. Once everything is ready, let me minimize this window a little bit so we can see the game itself. Now, the idea is whenever you have this start button, whenever you have this particular row of the tiles, and it's having a black tile on it, you need to press or just click on the black tile. So there are two things that we need to do. One is detect whether the tile is black. If it's black, then it should go ahead and press. So those are the two things that we have to simply do. Now, the first thing is to understand where the cursor is present, so we can then identify where all these pixels are to be used. So for that purpose, we'll use a simple function. We'll import PyAutoGui as py, and then using py, we will try to understand where the cursor is located. Import time, so we can do a continuous print out of where the location of the cursor is. Then we'll run a simple while through loop. This loop will help us read where the tiles are or where the cursor is located. So wherever the cursor is located, print py position and time dot leap. We'll give it 1 second. So what we're doing here is just having a simple while loop, an infinite loop, that will continuously read the position of the cursor by using py.position and print the position here on the terminal for us. We'll run this simply, and you can see that it's starting to print the location of our cursor based on where our mouse is located. Now we can see there are 4 columns that we need to point out. So the first column, it looks like the x-axis is at 356 and 657. So I'll note it down on a piece of paper here with me. So I'm noting down that x is 356 and y is 657 for the leftmost column. Then I move the cursor a little bit on the right side, and you can see that I'm taking the second column, and the x-axis is now 450. I can have the same y-axis that I had in the past because it doesn't matter how, because it's going to be the same vertical position. It's just the horizontal position that we are interested in. So I'll keep the same. In the past, we had 657, and I'll use 657 again. The next is the third column, and here I'm using x as 557. Similarly, the last column is going to be 654 based on the reading that we are getting here. This is done, so we just stop the program, and all this information is done. We don't need that anymore. Now, using this information, we need to make that program, that logic, which is basically supposed to read the graphics and see whether it's a black color or not. So for that purpose, let's also understand how PyAutoGui looks at the color pixels. So I can simply write a simple application. Again, import PyAutoGui as py and py get pixel or pixel, and it needs the location of x and y. And we know the black axis is located here. So this was as per for what I wrote down here. It's 557, comma 657 for the y-axis. So this will just print what is the pixel what's the color of the pixel at that particular location on the screen. If I just press enter, it gives me a value of 7, 17, 17, 17. So it means that all the colors are black, which is 17, and it's giving us that value. Similarly, if we give something else, pixel, and we have the 450, 657, and if you just print this, it's giving us 255, 255, which is nothing but the white color on the adjacent column. So this makes us believe that if it's a black color, the pixel is supposed to be 17. And if it's a white color, it's going to be 255. We're not going to bother ourselves with white color because there's too much of white and it'll be difficult for the system to detect all the whites. Instead, we look in the anomaly, which is the black color. So wherever the pixel is 17, it should go in and click. That's simple as that. So let's close this and we'll come back here and we'll write the program. Now we'll see from PyAutoGui, import everything. Okay, let's go ahead and import everything that we need. Good. Now let's import PyAutoGui separately. Now we need a little bit of a time function to monitor. And we would need the keyboard so that we can press the button. Okay, and then we can use import Win32 API. And this is in order for us to use the Windows functions, Win32 con as well. Now, the first step we will try to understand is wherever these locations are. So we will try to comment line for ourselves. The first column is equal to 356, 657. Now, this is based on my screen size, and it will be different for you in your case. Next, you have second column, which is 450 by 57. Then you have the third column, which is going to be 557 by 657. Lastly, we will have the fourth column, which is equal to 654, 657. Let's use this information and try to see whether the pixel is black or white. And for that, we'll create a while function while keyboard is pressed. And if you press Q, the function should stop. So we're basically saying if it's Q, you should stop. So we'll say false while it's false. Let's start printing all the functions that we need. And for that purpose, we'll do if PyAutoGui pixel at the location of the first column, which is 356 by 657. And we'll just read one pixel out of the three because it gives us the RGB value, which is 3. We'll just read the first one and we'll say if it is equal to, let's say 17, then you need to click at that thing. And for that, we'll create a click function and we'll give the values of the click function, which is 356 by 657. That's all. Right now, click is not defined, and we'll go into that a little bit. So let's copy this. And the same function is going to go ahead with all the other columns that we have to look for. And here, instead of 356, we have the 450. We'll put down 450 here for the second column. The next is the third column, which is 557. And we'll put it here. If 557, good. Then the last column, I did not copy this, so let's copy this back again. Come here. This is the last column, which is 654. And we put down here 654, 654, done. So at this stage, we just made a simple logic. So as long as Q is not pressed and Q is okay, I think we have these redundant brackets. We don't need so many brackets there. So as long as Q is not pressed, go ahead and check all the 4 columns one by one. If the first column is 17, great, just go ahead and click on this. Similarly, we're looking at all the 4 columns. Now let's define this click function. So click will basically take an argument, and we'll say define click. And we'll take an argument which is nothing but the x and y coordinate of where the cursor is supposed to click. And here we will now use the Win32 APIs that we have. Win32 API set cursor position to that particular x and y that we found out. So we do x, comma, y. Great. Once we have the cursor at that particular location, say in this case, it's going to be the start position. So we put the x over there, and now we tell Win32 to go ahead and click, which is the left click. We say Win32 API, please go ahead and give a mouse event. And this mouse event is nothing but the Win32 on dot mouse left down. We're just creating a left down 0, 0. This one nothing but just click the left button. Next is, once the left button is clicked, give it a few seconds. For that we'll use time.sleep, a few seconds, maybe about 0.1, and see if that works. We can later reduce it even more if we need. Same thing, Win32 API dot mouse event. Now once the left button is clicked, we also need to raise it up. So we just say Win32 on, instead of mouse left down, we say mouse left up in 0, 0. So that's about it. So I think we have everything coded here. This is supposed to take care of that. Let's see if this runs without any errors, which rarely happens. Go ahead and how this goes. And you have now using PyAutoGui and different types of Windows automation, including OpenCV and image processing, we can do self-driving on a game like this. That'll be the next project that we will take up on this channel. If it's something that interests you, stick around. With that, take care, stay safe, bye-bye.